In Lesson 20, we want to talk about factoring a little bit, and we want to talk about prime numbers. A prime number, when we factor numbers to prime, we're factoring down to the numbers that can only be divided by themselves in the number 1. In other words, 2 would be a prime number because we can only divide it by 2 and 1. 3 is a prime number. 4, however, is not because it can be divided by 1 or 2 or 4. So it has more factors in it. So we want to get down to primes. Let's do it with what we call a factor tree. I'm going to take the number 20, and I'm going to sort of draw 2 legs off this tree, and I'm going to think of any 2 factors of 20. I'm going to choose 4 and 5 because those are factors that come readily to mind. Now, 5 is prime, so I'll circle it because I can't take it any further. But 4 can be divided again. In other words, I can think of more factors of 4. 2 times 2 equals 4. Both 2 and 2 are prime numbers. When I have finished and I have all primes at the bottom, I can't go any further. I have the prime factorization. The prime factorization of 20 is 2 times 2 times 5. I use each of my factors, each of my prime factors, to multiply together. I could write that in exponential notation. I would say 2 squared. 2 times 2 is 2 squared times 5. That's the prime factorization of 20. Let's try something that has a variable term in it, 75 and a squared, 75a squared. Now, the variables are not really hard. We're just going to split them out first thing. 75 times a squared, okay? Let's factor each of them. 75, what 2 factors of 75? It doesn't matter where we begin. You could begin with 5 as a factor, but I always think of 75 as quarters, so I'm going to say 3 times 25. Well, 3 is prime, so I'll circle it. 25 I can factor again. 5 times 5 gives me 25. Both of those are prime, so I'm through with 75. What about a squared? Well, a squared is pretty easy. A times a. Once I have a variable down to just a single variable, that's its factorization. So how do I factor 75a squared? I'm going to start with the small numbers. 3 times 5 times 5 times a times a. If you were writing in an exponential notation, using exponents, you'd say 3 times 5 squared, that's 5 times 5, times a squared. That's a times a. Now, we're going to use factoring to primes just for some practice, and we're also going to use it to simplify some of these fractions. You know, you simplify a fraction by dividing both the numerator and the denominator by the same number, but sometimes we can't tell what that number is, and we can't tell if we've divided it down to its lowest form. Factoring to primes will do that for us. Let's take the numerator of example 1. Let's take the number 4 and see what the prime factors are. Well, of course, it would be 2 times 2 would give us 4. So I'm going to write this like this. I'm going to write the numerator up here, and I'm going to say 4 is equal to 2 times 2. Now, 42 is a little harder to factor. It's a little more complicated, but we can do it. I always start off with 2 if it's an even number. 2 times 21. 2 is prime, of course. And 21 I can factor again. 3 times 7. So I think I've factored it down to the prime factors. What are they? 2 times 3 times 7. Now, I've written my fraction, 4 over 24, as a product of primes. And now I can cancel out anything over itself really equals the number 1. So what we can do is we can cancel out pairs that match. In other words, I have one set of 2's that matches in my problem, in my fraction. So I can cancel those. They become 1's. Well, that's all that matches. So what's left in the numerator? 2. In the denominator, 3 times 7, or 21. The lowest form of 4 over 42 is 2 over 21. Well, you could have done that by dividing both the numerator and the denominator by 2, but we need a little practice in factoring to primes because there will be some numbers that you just can't see later on. Let's work on example 2. Now, if you can see the prime factors, like we probably can with example 2, just go ahead and write them down here. 9 factors into 3 times 3 times y, right? That's easy. We don't really have to write that down. But let's look at 48. I may have to work at 48. Like I said, I usually start if it's an even number with the number 2. So 2 times 24 would give me 48. And then 24 is another even number, so 2 times 12 would give me 24. And 12 is another even number, so 2 times 6 would give me 12. And 6 is another even number, so 2 times 3 would give me 6. There, I'm finished. What do I put in my denominator? Well, 2 times 2 times 2 times 2 times 3. That's 48. Do you see any factors that match? If you do, you can cross them out. I see one set of 3's that I can cancel. What's left in my numerator then is 3y. What's left in my denominator is 2 times 2 times 2 times 2, which is 16. The lowest form of 9y over 48, 3y over 16. All right, let's take example 3. We're going to factor 45b. I'm just going to factor 45 because I know b is just going to factor into plain old b. 45, 5 times 9, and 5 is prime. 9, 3 times 3. Well, that wasn't too hard. I probably could have done that in my head. But let's write it down here anyway. This is equal to 3 times 3 times 5. If you start with the smallest numbers and work your way up, usually you make fewer mistakes that way. Oops, and don't forget, if there's a variable, times b, right? Now, 80, let's factor 80. Once again, this is an even number, so 2 times 40, 2 is prime, 40. 2 times 20, 2 is prime, 20. 2 times 10, 2 is prime, and 10, 2 times 5, and both of those are prime. So 80 factors into 2 times 2 times 2 times 2 times 5, b squared. What's that? b times b. Let's cross out anything we can that matches. Well, there are no 3's that are common to both. There are no 2's that are common to both. There's one set of 5's and one set of b's. What's left in the numerator then? 3 times 3, or 9. What's left in the denominator? 2 times 2 times 2 times 2, or 16, and 1b. So it's 16b. That's our lowest form. All right, you should work the other 3 without my help, and then turn your tape back on and check your work. Let's take number 4 and factor 60 into primes. I'll factor 60 into 2 times 30, and then I'll factor 30 into 2 times 15, and I'll factor 15 into 3 times 5. I'm going to write that as 2 times 2 times 3 times 5, and then I have to take care of these variables, times a times b, a squared b. That's a times b. Okay, let's look at 36 now. 36, I can factor that into 2 times 18. Could start with 6 times 6, but this is easier for me. I can factor 18 into 2 times 9, and I can factor 9 into 3 times 3. So 36 is 2 times 2 times 3 times 3. Now I have to do my variables, times a times b times b times b. b cubed, 3 b's. All right, let's cross out matching terms. Well, I've got one set of 2's that'll go, another set of 2's, a set of 3's, nothing to do with the 5's. But look at my a's. I can cross out a set of a's and one set of b's. Okay, what's left? In the numerator, 5a. In the denominator, 3 and b times b, which is b squared. The lowest form of that one is 5a over 3b squared. Example number 5. Let's factor 40. It's going to be 2 times 20. And 20 would factor into 2 times 10. And 10 would factor into 2 times 5. Okay, those are my prime factors for 40. So I have 2 times 2 times 2 times 5 times the variables. Don't forget the variables. Times x times y. 64. I'll factor 64 into 2 times 32. You could have chosen 8 times 8, of course, and gotten started that way, and then factored both of them, but this is easier for me. 2 times 16 is next for 32, and 16 factors into 2 times 8, and 8 factors into 2 times 4, and 4 factors into 2 times 2. All 2's. How many 2's do I have? 1, 2, 3, 4, 5, 6. All right, 1, 2, 3, 4, 5, 6 2's times x times y times z. Now, crossing out matching ones. Got one set of 2's, another set of 2's, a third set of 2's. That 5 isn't going to match anything, but here's a set of x's. It's really hard to cross out x's. You have to be careful. And then a set of y's will go. Okay, what's left in the numerator? 5 and no variable. In the denominator, 2 times 2 times 2, that's 8. And z. What is my simplified version? 5 over 8z. And the final problem, I have 36, which I will factor into 2 times 18, and 18 will factor into 2 times 9, and 9 will factor into 3 times 3. The prime factorization is going to be 2 times 2 times 3 times 3 times, I've got a lot of variables here, x times x times x times y times y. Okay, good. Almost ran out of room. Now, number 24. 24. 2 times 12. 12 factors into 2 times 6. 6 factors into 2 times 3. Eventually, you'll be able to do these almost in your head. 2 times 2 times 2 times 3 is 24. Times x times y. Let's cross out the matching factors. The 2's match, another set of 2's, one set of 3's. Here's an x, carefully crossing it out, and one set of y's. Now, what's left in the numerator? All I've got is 3x squared y. In the denominator, I've got 2, and that's all I have. So it simplifies down to 3x squared y over 2.